All right, class. Section 8.4, Day 2, Properties of Rhombuses, Rectangles, and Squares. So let's look at some more examples and things we can do with this knowledge of what the characteristics are of rhombuses, rectangles, and squares. So for example number 1, for any rhombus that we'll call RSTV, decide whether the statement is always or sometimes true. And we'll draw a sketch and explain our reasoning here. So looking at this first one, we want to know about angle S being always or sometimes congruent to angle V in a rhombus. So we want to draw our rhombus. I'll draw it maybe here in the middle. This is rhombus R, S, T, V. Now remember what we know about rhombuses. 4 congruent sides, diagonals are perpendicular, and each diagonal bisects a pair of opposite angles. So we know 4 sides are congruent in our rhombus. We know diagonals are perpendicular. And we know that those diagonals will bisect the angles that they go through. Okay, so we're looking at angle S and angle V. So will S and V always or sometimes be congruent? And they're going to always be, this is always true. They will always be congruent because they are opposite angles. That is one of our parallelogram characteristics, that opposite angles are congruent. Both pairs of opposite angles congruent. So S and V congruent, always true. And our reasoning, opposite angles are congruent. Opposite angles congruent. And I'll use red for letter B, T and V. With T and V being congruent. Looking at the red marks here. T and V, we know it's a rhombus. So in a rhombus, again, we know our 4 congruent sides, our diagonals are perpendicular. Each diagonal is going to bisect a pair of opposite angles. And we know the opposite angles are congruent, but that doesn't mean in a rhombus that the consecutive angles are congruent. We know the consecutive angles have to be supplementary, but they don't have to be congruent in a rhombus. A rectangle, they would have to be. So this is only going to be sometimes true. Sometimes true. Because adjacent angles are only congruent when a rhombus is a square. Or consecutive angles, either one, adjacent or consecutive. So it would have to be a square for those angles to be congruent. So those angles would have to be 90 degrees. Because remember, a square is always a rectangle. It is always a rhombus. but a rhombus is not always a square. And so for those to be congruent, it would have to be a square. So it is sometimes true. Classify the special quadrilateral and explain our reasoning. We have 4 congruent sides, so it will be either a rhombus or a square. That is one of our rhombus characteristics, 4 congruent sides. But then if we look at the angles, is there anything we could pull that would prove it to be a square? Looking at our angles, we have an angle of 127 degrees. That's not a right angle, so it can't be a square. It has to be a rhombus. See if you can figure out this next one on your own. We know it's a parallelogram. It's got 2 pairs of opposite sides that are parallel. We have the 2 consecutive angles are 90 degrees. And I know with it being parallelograms, my consecutive angles are supplementary. So if these 2 are right angles, then the other 2 have to be right angles. So I know it's either a rectangle or a square because it's got 4 right angles. Then if I look at my side lengths, I have a side length of 3 and a side length of 6. So my sides are not all the same length, so it has to be a rectangle. So we're going to classify these special quadrilaterals, explain our reasoning, then find the values of x and y. So classify first, and then we can find our x and y. So we've got 4 sides that are congruent. So that's one of our characteristics of a rhombus, 4 congruent sides. So it's either a rhombus or a square. But if we look at angle Q is 97 degrees, which is not 90 degrees, which is what we would need for it to be a square. So this is a rhombus. We have 4 congruent sides. And then we need to solve for x and y. Let's look at x. We have 5x plus 6, and we have an 8x. We know our sides are congruent, so we can set those up equal to each other. 5x plus 6 equals 8x. We want to combine our like terms, so I can just subtract 5x on both sides. Gives me 6 equals 3x, and then to get x completely by itself, divide by 3. And x equals 2. Then I need to solve for y. For y, I have 12y minus 1 is angle P. And I don't have any other y's anywhere, but my other angle I know is angle Q of 97. Now these are not congruent angles. Remember, in a parallelogram, your consecutive angles are supplementary. So we know it's a rhombus, so I know my consecutive angles are not congruent, but they will be supplementary. So that means I have to add up to 180. So 12y minus 1 plus 97 equals 180. So I get 12y, and then negative 1 plus 97 gives me, get that plus in, or 12y in there. So we get 12y plus 96 equals 180. I can subtract the 96 from 180. 12y equals 84. And then I divide by 12, and y equals 7. Now you may have looked at that and said, well, all right, if I know that they are supplementary, I can just subtract 97 from 180, and that gives me 83, and then I know 12y minus 1 equals 83. So either way, actually setting it up like 12y minus 1 plus 97 because both angles have to add up to 180, and figuring it out that way, or just subtracting 97 straight away, and you'll still get y equals 7. All right, and then on our next quadrilateral, we can see all four sides are congruent. All four angles are right angles. And our diagonals are perpendicular. So this is a square. We have something from both rhombus and rectangle to tell me that it's a square. So to determine something as a square, you do have to be able to find one characteristic of a rhombus and at least one characteristic of a rectangle. So we know our 4 right angles and 4 equal sides. Four right angles and 4 congruent sides. We get the 4 right angles from rectangles and the 4 congruent sides from rhombuses. So we've got our square, and then we can solve for x and y. But first look at x. Got a 2x plus 1 and a 4x minus 7. For my sides, I know my sides are congruent, so they just equal each other. 2x plus 1 equals 4x minus 7. So I'll subtract 2x from 4x. I'll add 7 to the other side. Gives me 8 equals 2x, divide by 2, and x equals 4. Okay, then for y, I can see that 7y plus 3 is the measure of that angle. I know that angle, well, in this case, it's just pointing to this section of the angle. If the large angle is 90 degrees, then half of that, because I know my angles are bisected, because a rhombus tells me that each diagonal bisects a pair of opposite angles. So this 90 degrees is bisected, split in half, that smaller section has to be 45. So 7y plus 3 equals 45. So I can subtract 3. 7y equals 42. Divide by 7. And y equals 6. So just pay close attention to where, if, for in this case, that arrow is, where that arrow is pointing, it's pointing toward that lower angle. If it looked like it was pointing right in the middle, then we could just say, hey, it's 90 degrees, so 7y plus 3 equals 90. So either way, I could have set this up either way, but this was looking specifically at that smaller section of the angle. And we can see that that was bisected by those diagonals. So I know that it is a 45-degree angle. Last example. The diagonals of rhombus ABCD intersect at point E. Given that angle BAC is 53 degrees, so that's this angle here is 53 degrees, and DE is 8, find the indicated measures. So we're told it's a rhombus. Because it's a rhombus, what are the things we know? We know we have 4 congruent sides, we know the diagonals are perpendicular, and we know each diagonal bisects a pair of opposite angles. So I know my diagonals are perpendicular, and I know that they're going to be bisecting each other, so I know that's congruent to that. These are congruent to one another. I know that the diagonals bisect angles, so if angle BAC is 53, then this the other angle there has to also be 53. So let's look at what we need to find. Measure of angle DAC. So that's the one I just wrote up there, 53 degrees. So measure of angle DAC is 53. Measure of angle ADC. I'm going to go ahead and erase that so it's not as cluttered. ADC is our angle down here. Now we know this is 53 up here, so if I add my two 53-degree angles up there, that will give me the angle of BAD, that large angle up there, which would be 106. So I know 106 plus ADC is going to equal 180. So I have 106 plus whatever we have for ADC is going to equal 180. So I can subtract 106 from 180. So the measure of angle ADC is going to be 74. So I've got 74 degrees for that angle down there at the bottom left, the whole angle. And I know that it's bisected, so if I need to, I can just divide that by 2 to find those smaller angles. But we'll cross that if we need to. Next is AE. So I'll erase this green work. AE is that segment there. How could we figure out AE? I'm just going to call it X for now. I know it's not 8. This is a rhombus. For those to be equal, for that to be 8, it would have to be a rectangle or a square. Or for this rhombus, it would have to be a square. So it's not 8, because it is a rhombus, and I know this rhombus is not a square, so these diagonals are not equal. So how else could we figure out 8? Well, what we do know is that that's a right angle, so that means this is a right triangle. And if it's a right triangle, what do I know with this? I know this angle up here is 53 degrees, which tells me also that this angle down here is 37 degrees, because they need to all add up to 180. So now, when we know an angle, and we know at least one side, how can we find a missing side? we can use our trig ratios, sine, cosine, or tangent. So looking at what we have, we don't know anything about our hypotenuse. That would be the outside leg there, or the outside side. But we do have our two legs, 8 and x. So depending on which angle we use, we'll still use tangent, but that'll determine which one is opposite and which is adjacent. So if I use 37, it's a smaller angle on us right here, so I'll use tangent 37 equals opposite over adjacent. That would be x over 8. X would be my opposite side from 37. 8 is the adjacent side to 37. And then to get x by itself, we multiply by 8 on both sides. And you just need to punch that into your calculator. So we have 8 times tangent 37. That gives me 6.028. I'll just round that to 1 decimal, and that'll give me 6. So x equals 6. So AE is 6, or 6.0. Will be a little bit more appropriate. Measure of angle AED. So I'm going to go ahead and erase that work we just did. AED. Well, that's the angle that just told us that we had a right triangle there. I know that's perpendicular because our diagonals need to be perpendicular in a rhombus. So perpendicular means 90 degrees. AED is 90 degrees. Okay, next we're looking at DB, side DB, or segment DB. That's the entire diagonal there. I know my diagonals bisect, so AC bisects DB. So I know those two sides of that diagonal are congruent. So this side also has to be 8, so the entire length is 16. And then AC, we found what x was. This was 6, so this also has to be 6. So AC, the entire length is 12. All right, that's it on the notes. Be sure to do your homework.